I'm going to do my best to tell you about the risk of rapid sea level rise. I represent the geologic school of thought, which is a little bit different than the mainline IPCC reports and scientists. And I'm going to couple this with thoughts on how to deal with this, because we've known about this for now 40 years. The first is to understand that Antarctica has been pressed down by millions of years of thick layer of ice. Most of it is below sea level if you take the ice off. This is different than the maps that were published, say a decade ago, that showed most of it was above sea level. Glaciers that rest on land are very different in their behavior than glaciers that have their feet in the water, because as the ocean warms, you can get at the base of the glaciers. And glaciers are a bit like elephants. They don't like warm water at their feet.
He has a son at Tulane.
The seminal report that came out in 2020 was of ocean current acceleration. This was produced by the Woods Hole Institute of Oceanography. And this is their map of the relative accelerations around the world of the oceans. And they're accelerating by their estimate 15% per decade by energy. This is driven. This is the area that is the chief concern, is the Thwaites Glacier and the surrounding glaciers, because we had this experience in 2002 of the Larsen B ice shelf breaking up, and there were three criteria. There were the temperature of the ocean, the amount of rock that was holding it back, and the relative air temperature above it. And what we know now is that the oceans are up to 2 degrees Celsius above freezing, where they used to be 2 degrees below freezing. The basic mechanism that is driving all of this in Antarctica is that cold air settles in the top of the dome, which is about 8,000 feet, and sweeps to the ocean. And so as the world heats up, it drives this engine faster and faster in the unique style of wind that's called a catabatic wind. If I had a cat, I would name it catabatic. It's just a very catchy word. But this creates a pressure against the ice shelves, pushing them away from the continent and causing the upwelling of deep water faster and faster. And this is accelerating by some estimates between 4 and 5% a year. The slide on one side shows the relative acceleration of these ice sheets. And so it isn't just the coast that it's accelerating, it is reaching very deep into the interior, and it's not spread out. This, per glaciology, when glaciers accelerate, they do all sorts of odd things. Ice doesn't like to move fast. And the second is the image on the right. There's no. This is a map of the seafloor that has been done by. I remember they did a radar, but they penetrate the ice to see what the elevation is, and it's very deep behind this area of rocky mountains, essentially, and these are 1,000 feet underwater. This is the grounding line, so there's not much after it loses purchase here. There's nothing to hold it back, and because of this, everybody and their cousin Luke, the British, the Americans, a lot of nations combined, and they spent a total of $50 million of research money, which is an unprecedented amount for a single glacier. That gives you an idea of how big the risk is and how it's really caught the scientific world's attention. And the key finding of the research so far is these crevasses on the other side of the glacier. So as the ice moves out and accelerates and pushes against the last of the rocky slope, it forms these very large underwater crevasses. So the concern is the top of the glacier can look perfectly fine. It's the real action is happening underneath. And due to the landscape, I live in Washington State in the Puget Sound, which was heavily glaciated, in the last ice age. we know that you have these very deep channels that are carved out wherever the rock was soft by the glaciers. And so, although it shows a hump here, there are all these channels that run through it that allow warm water to be conducted. And as the glacier lifts up and down with the tides, it pumps warm water all the way into the back. We notice it gets farther back than we ever thought. This is already beginning to show up in places like Florida. This is the foundations of the tower that fell. And I just put it up there because the novelty is that during high tide, it floods. And so this is already a problem for a lot of real estate in Miami. So what can we do about this? I could go at length and describe more of the detail of this, but it all comes about the same, that if you don't really couple solutions with a risk, you're just the bearer of bad news. And the good news is that same statistic of the ocean currents accelerating 15% by energy by decade, that means wind energy is accelerating 15%, at least 15%. And this is a map of the available wind energy around the world, at least, and it shows that you have a very rich amount of wind energy over Africa, the United States plains, the coast of Alaska, and up in Scandinavia and the British Isles, Iceland and Greenland. These are the places that are going to be very energy rich in the future. There's been significant developments in offshore wind turbine structures where before they had to have a fixed pole, it was like a foundation. And now they're using the same technology that they use for oil drilling platforms to make these floating structures. This means that you can open up progressively larger areas of the ocean to wind turbines and wind energy. And wind energy is really desirable over the oceans because it's very consistent. You don't have a landscape to break it up. It's not like land will get real hot during the day and cold at night. The second is they perfected, they add little whistles to the blades, and they don't get the bird strikes that they once do because the birds can hear the turbine blades. This is a screenshot of the process that is used in the oil and gas industry to remove hydrogen sulfide. It's also the same technique of using carbon dioxide from the atmosphere. And so the more plentiful and cheap you make electricity, the more you can drive this process to essentially compress air, react it with amines, and get it out of the atmosphere. And once it's out of the atmosphere, you can figure out what to do with it. But this is it all predicated on the price of electricity and the efficiency that you can do this reaction. This was a news story out of China where a scientist crossbred a strain of rice with a strain of wild grass that grows in the salt marshes. The result was the highest yields in China. And this was on land that was previously too alkaline and too saline to produce anything. And so saltwater aquaculture in a variety of forms, it has tremendous potential. You look at the world in arable land, you find that there are these vast deserts in the southwest of the United States, all of the Sahara in the Middle East, significant parts of South Africa, and in China, where they have these low-lying areas that were previously not productive. They can now be some of the best cropland in the world. There's an added benefit of this, is that if you create saltwater aquaculture by just pumping saltwater on land in a place like this, you create clouds downwind. You will actually create a habitable environment to support people. And the carbon sequestration in the soils that you create traps about a centimeter per year of carbon dioxide. It works out to the equivalent. And if you're looking at a cost-effective way at capturing billions of tons of carbon dioxide, this is at the top of my list. There's innovations in housing. The old style of housing, you built a foundation, you used wood, and you framed it up. New style of housing is increasingly using these metal structures that were pioneered for containers. This is a artist rendition of a high-end house, but the fact that architects are beginning to really realize the potential of these kind of spaces, because the cost of this housing is somewhere around a third of traditional housing. And so if you're looking at providing housing in a cost-effective way for millions of displaced people, this is the solution. Not exactly this, but some variation of this. There are huge improvements in battery technologies. Electric cars in the last 10 years, if you really followed this, it's had huge improvement. And I can't understate that you have this weird thing about patenting and intellectual property that you don't really know what's in the pipeline to come out even next year or 5 years from now, because as a person invents something, they have to get funding for it. They have to go through a patent process. And so in the case of lithium sulfur batteries, this was announced because a researcher at a university thing, and it has 4 times the density of power. Now, I just put a question mark on this, and that it may or may not be a big factor in the future. But there's almost 50 other things that have the same potential, and you really never know which one's going to win. And there's all I can say is the more you know about these potential things, the more you're hopeful. Well, lastly, I'm going to point a little cute picture of a pig, because the raw fact in our modern society is that they genetically engineered a pig, and so that it had a human internal organs and the outside appearance of a pig. This portends a raft of medical innovations. Everything in healthcare spending is about 20% of our GDP. If you make healthcare more efficient and allows better quality of life, you are going to change our economy so it's more able to spend money on climate remediation. It's just a simple fact. All of these things compete for dollars. And so if you save money here, you're going to make more money available there. And the last, if an old lady has 5 Schrodinger cats, how many does she need to feed? This is a joke in geology and physics to say, how much do you actually know? And the answer is 2.5 of them. Because the whole thing about a Schrodinger cat is it may or may not exist. It has a 50-50 chance. That was the whole idea. And so I really invite you to say, we don't know what the future holds. We don't know what's going to come around that might be good. And you just have to have a certain optimism and greet whatever comes your way.